Welcome back to our data analytics series. In today's video, we will dive into logistic regression, a powerful classification model used for predicting binary outcomes. You'll also learn how to evaluate classification models using metrics like accuracy, precision, and recall. By the end, you'll be able to build and apply logistic regression in a real-world scenario to predict customer churn using Python. We will be looking at the following contents in this video. Classification models are used to predict categorical outcomes based on input data. These models are crucial in a wide range of applications, from detecting fraud in financial transactions, filtering spam emails, to diagnosing diseases based on medical data. Logistic regression is a classification technique used when the dependent variable is binary, meaning it has two possible outcomes, such as yes or no, true or false, or 0 or 1. Instead of predicting a continuous value like linear regression, logistic regression predicts the probability of a given outcome, which can then be converted into a class label. The main difference between logistic and linear regression lies in the type of prediction. While linear regression is used for predicting continuous values, logistic regression predicts probabilities that are then mapped to binary outcomes. This is achieved through the sigmoid function, which outputs probabilities between 0 and 1. The logistic regression formula calculates the probability of a given class using the logistic or sigmoid function. The formula is P, x, equals 1 divided by 1 plus e raised to the power of negative z, where z is a linear combination of the predictor variables. The resulting probability is then mapped to either class 0 or class 1. The sigmoid function is a key component of logistic regression. It takes any real number input and maps it to a probability between 0 and 1. The threshold is usually set at 0.5, meaning that if the predicted probability is greater than 0.5, the model predicts class 1. Otherwise, it predicts class 0. Logistic regression is widely used in various industries. For example, it's used to predict whether a customer will churn, diagnose whether a patient has a certain disease, or score creditworthiness by predicting the likelihood of loan default. Its ability to model binary outcomes makes it incredibly useful in decision-making processes. To evaluate the performance of classification models, we use several metrics. Accuracy measures the overall correctness of the model. Precision focuses on the proportion of true positives out of all predicted positives, while recall measures how well the model identifies true positives out of all actual positives. The F1 score balances precision and recall, providing a single score to evaluate the model. Let's apply logistic regression to predict customer churn. In this example, we'll use customer data, including features like age, tenure, and account balance, to predict whether a customer will leave the company, also known as churn. The goal is to create a binary classification model where 1 indicates churn and 0 indicates no churn. We will be working on this file, and our dataset is already loaded here. First, we import the necessary libraries. Pandas and NumPy are used for data manipulation, while scikit-learn provides tools for model building and evaluation. Next, we load the dataset and display the first few rows to get a feel for the data. We then select the features we'll use for prediction, in this case, age, tenure, and account balance. Finally, we split the dataset into training and test sets to evaluate the model's performance on unseen data. Now, we initialize the logistic regression model using scikit-learn's logistic regression class and train it on the training data. After training the model, we make predictions on the test set and evaluate its performance using accuracy, precision, recall, and the F1 score. These metrics will give us a comprehensive view of how well our logistic regression model is performing in predicting customer churn. And here got predicted model evaluation results. In this video, we explored logistic regression, a powerful tool for classification problems, and learned how to implement it in Python to predict customer churn. We also discussed important evaluation metrics like precision, recall, and the F1 score. In our next video, we'll dive into decision trees and random forests, two advanced algorithms used for classification and regression tasks. Be sure to subscribe and turn on notifications to stay updated.